Ferraro, and I'm going to talk to you about integrating application the reactive way. This is the first time that I do this talk, and actually I feel very lucky because, I'm going to talk about Camel, I'm going to talk a bit about Vertex, and in the audience there is Klaus, that is the Camel guru, and also Clement, that is the Vertex guru. So I'm really happy about this. I'm not under pressure, at all. I was thinking to do this talk in Italian, so they don't understand. Se parlo italiano mi capite voi? Sì, posso parlare. Ok, sono Nicola Ferraro, lavoro per Red Hat. Okay, just joking a bit. I am Nicola Ferraro because they call me Nicola, not Nicola. I work for Red Hat. I work mainly on Apache Camel. I'm a committer for Apache Camel, but also on some Fabricate projects. Fabricate has 1,000 of projects, so I work mainly on the Fabricate Maven plugin. And if you mix Apache Camel and the Fabricate, you get JBoss Fuse integration services that are Red Hat products. So if you want to know more about them, just ping me. So today, I'm going to talk about a different thing. It's Camel integration and reactive applications. But first of all, what is reactive programming? I don't like definitions at all, and instead of giving you a definition of reactive programming, if it even exists, I would like to share with you what's in my mind when I think about reactive programming. What do I think? And when I think about reactive programming, I think about a game like this. Okay, I never played this game. It's a game from Disney. So suppose that you have to write an application to solve this really difficult problem. When you press the launch button, you have to put a marble into the bucket. Okay, so there are 1,000 infinite ways to solve this kind of problems. You can just throw the ball into the bucket. You can design an helicopter that takes the ball and then flies and put the ball into the bucket. But I think that there are a set of ways to write this kind of application that I call reactive. They are reactive according to my mind. It is this kind of way to design an application. So you design a schema, okay? And the schema is idle. Nothing moves in the application. And things start to move when you press the button, and the first ball enters the game. It is the first event coming into the stage. And then the first event causes other events. For example, the domino falling down. You see it here. And then another ball falls here, and then you have a kick, and then another ball falls here, and then you have 2 punches, etc., etc. But at the end of the day, if you can watch this game on YouTube, a ball will fall into the bucket. But why I think this is reactive programming in my mind? Because it's a series of events that generates other events, like in a chain reaction. We'll see more about this later. But I think I should be less abstract. This is an example of reactive programming. It can be Reactor Core or Java 2, or also Scala. The syntax is similar for any reactive programming framework. Reactive programming is about streams. You have here stream 1, stream 2, stream 3, and also operator like map, zip, filter, subscribe. It's not an operator. But what do they mean? What is a stream? A stream is like a pipe where events flow inside, like water. And this is a stream 1, and then we have a map operator. What is the map operator? It's a box applying a function to every event coming inside. In this case, it changed the colors to yellow. Then you have a zip operator with another stream. This is the stream 2, and the zip operator is just another box like this. You remember the WinZip icon? It's a press. The zip operator takes one element, one event from left, one event from right, and then zip them together and produce a stream with one event from 2. Then you merge the result with the stream called stream 3, and the merge operator is easy. Just take what comes from top and what comes from left. Then you filter what is almost round, yeah, and put the ball into the bucket. Okay, this is why I think that this kind of application, this kind of programming is like playing that game, but it's something that is in how my mind is reasoning about reactive programming. I would like to share this with you. Yeah, it's not so static. You can also have dynamic calls in a reactive application. You see here, these are the schema that are used usually to explain operators in reactive programming. They are called marble diagrams because marbles are the little balls flowing into the streams. Okay, and you have operators like flatmap where you can use, for example, to call another function asynchronously and get a result that is a stream containing 0, 1, or more result, and then you merge the stream into a bigger stream. So you can do request-response pattern also with this kind of approach. But okay, let's talk about the difference between this approach and what I call standard programming, non-reactive programming, trait-based programming. Okay. Trait-based programming, in my mind, is something like this. Yeah, Super Mario Bros. So this is Super Mario Bros. 3, a really beautiful game. Look, Super Mario has to wait in this moment because, in this kind of program, there are multiple traits, the bullets in the screen. And then Super Mario wants to go faster, but it has to stop here and wait for the bullets to pass and then continue. Okay, you have resource contention, lock, wait, notify. So if you look at this application this way, you feel immediately that, reactive application can be faster than standard application, whatever it means. And yes, I remember a few years ago when a friend of mine came to me and say, oh, look, JavaScript is faster than Java. Oh. How the hell is this possible? Yeah, also on multi-core machines. Yeah, no, it's impossible. Actually, there were I was starting to see some benchmarks a few years ago stating this. If you try on a multi-core machine, a Tomcat, using synchronous operation, on a multi-core machine, and you try on this same machine one Node.js application using one single thread, and there was no way in 2011 to use both cores of the machine, there were some benchmarks stating that Node.js was faster than Java. Okay, even if Java was using both cores of the machine in a two-core machine. Well, how the hell is this possible? It's possible because Node.js was one of the first frameworks using this kind of pattern, the reactor pattern. Basically, instead of binding one thread to serve one request coming from outside, Node.js has a different approach. It transforms each request into an event, and the event is stacked into an event buffer. And then it has an event loop thread that does always the same thing. Take an event from the buffer, call the event handler. Take an event from the buffer, call the event handler, always. Always the same thing. Actually, the event handler, what can do? It can do a synchronous I.O., not synchronous I.O. because synchronous I.O. is blocking. You cannot block this event loop. It can generate other events. You see, like in a chain reaction, like in that game, an event that generates other events that are stacked, and then eventually they are all served. I think that this is probably why this is called a reactor pattern, because, in a nuclear reaction, you have these kind of events generating other events. And you have, more recent patterns based on this are, for example, the multi-reactor pattern used in Vertex, where you have, I think, 2 event loop for physical core on the machine. So with no concurrency issues, they are solved by the platform. The golden rule is never block the event loop. If you block the event loop, the event can stay there and will never be executed by the event handler. So there are some benchmarks setting, the difference, for example, using a synchronous approach with an asynchronous approach with the event loop. This is Tomcat against a Rex Netty. If you have programmed using the servlet, the synchronous module of the servlet, you know that you are not using thread.sleep or synchronized block. Usually what you do is, okay, take something from the database and return it, so you don't have a lot of synchronization code. So why this asynchronous approach is faster if I don't block in my program the application? Yeah, the reason is that in a synchronous approach, you have to put a lot of threads, 100, 1,000 threads, depending on the load that you want to handle. And when you have a lot of threads, you have a thread migration from one core to the other. You have context switch and also slower garbage collection. And if you want to, for example, handle in one application server 10,000 connections concurrently, you have to create 10,000 threads. And by default, 10,000 threads use 10 gigabytes of RAM for doing nothing. So if we want to have a 10 million connection in one single server, okay, you should go away and find another solution. So far, I've talked about reactive programming, but reactive systems are another stuff. Reactive systems are a distributed system that communicate using a message-driven approach with location transparency. Vertex is a toolkit for building reactive systems. It has an event bus for this. And reactive systems should be elastic. They can scale, react to the load, to the change in the load. Reactive systems should be resilient. If something fails, they should recover from this failure. At the end, the goal of a reactive system is to be responsive, reply rapidly to the users. So, yeah, this is the definition. I don't like definitions because I cannot classify a lot of systems that claim to be reactive. So I know for sure that Vertex is a toolkit for building reactive systems, AK2 for the actor model. ReactiveX, Rex Java 2, Project Reactor, a framework for using reactive programming. But yeah, I cannot classify, for example, Spring 5, because yeah. What about the location transparency and message-driven approach of reactive system and also other stuff? Yeah, but yeah, what I will say will apply also to this kind of frame, but I don't want to classify them. So, okay, I'll talk about reactive system, reactive programming. Let's talk about integration. That is the other topic of this talk. What is integration? Nobody lives in isolation. You know, we tend to always create distributed systems. And if we use a microservice approach, we split our domain logic into multiple bounded contexts. Each microservice uses its own bounded context. The purpose of this integration is make this application, separate application, communicate by converting protocols to let them communicate, by converting object of each domain to let they solve some business task. Okay, it's about routing, flow control. There is an entire book written by Gregory Hope and Bobby Wolf that is called Enterprise Integration Pattern. And this book actually has inspired the creation of the most fantastic framework in the world, that is Apache Camel. And this is the new logo that is going to be, yeah, it's not official, it's just a proposal for now. But Camel now has 10 years. You can say it's 10 years old, or it's a really mature project. But actually, it is actively contributed. A lot of contributors come from Italy. There's me, Andrea, and Luca, yeah, a lot of people. And now Camel has more than 200, probably more than 250 components. This is the list. Yeah. You can find DNS, Docker, Facebook, Open Tracing, Rex Java 2, Spark, Telegram. Yeah, a lot of components. Camel can connect everything in the world. And using Camel is really easy. Camel has natively a concept of stream, because you see here, this is a basic program. You can tell Camel, take the message from this message broker using JMS protocol from the orders queue. Then, okay, log the message. Then call this service, take the result of this call, and then send me an email with these 4 lines of code. Okay, so look at how this to operator in Camel is close to the map operator in reactive programming. Yeah, they are very close. And you can do also complex things in Camel. For example, yeah, take file from HDFS and then marshal to get a JSON array, for example. Then split to get a single element contained in that file, and then for each one, if they satisfy some condition, write them to JDBC, etc., etc., otherwise do other stuff. You can do a lot of things. Camel has a lot of enterprise integration patterns already implemented in the core. For example, suppose that you receive a lot of messages from Internet of Things stuff, and they are out of order. You want to sort them before processing. What can you do with Camel? Just tell Camel, okay, resequence based on one header, using a time window, for example, and then Camel will sort the message, and then you can continue processing. Or you receive the order, the item in your order separately, you can tell Camel, just aggregate using a time window. And also, yeah, content-based routing. You receive a message based on the content of the message, you route to one endpoint, that can be JMS, HTTP, whatever, or another, or also multicast the message to different endpoints based on the content on the message. This is, yeah, something that makes Camel really powerful for enterprise integration. Other enterprise integration pattern, like, for example, Istrix, it was shown by Klaus yesterday. Istrix is about circuit breaking. If you have a microservice that is going slow or replying with the errors, for example, you can open the circuit and return to the client fallback response to let the service to recover. We'll see more about this later. And yes, the question, is Camel reactive? Well, Camel 3, that will be the next big version of Camel, will have a reactive core. What does it mean? It will be based on event loop, like any reactive application. But yeah, Camel 220, this next major release coming shortly, is not synchronous. It doesn't use a one thread per request model. It's asynchronous by default. You have probably many thread pools inside, but yeah, you don't need to put 100 threads to serve 100 requests. You can use the asynchronous I/O in many components in Camel. We have Jetty, Netty, Undertow. And yes, most of the core is asynchronous, so it is fast, especially with the latest improvement made by Klaus in the recent months. So it is really fast. It is not reactive in the core, but it will be. We want to jump into this reactive train, but it can be used to integrate reactive systems. What does it mean, integrating reactive systems? Yeah, suppose that you have this reactive system. It is using Vertex. In this case, we have two microservices and a browser, communicating using the event bus. The event bus is not as a physical entity, it's a logical entity. And in some way, applications can send messages to channel, to name a channel, and then communicate using this logical event bus. So suppose that you have to integrate, so use some business logic implemented in one other system, a set of microservices. It can be a reactive ecosystem or a non-reactive ecosystem. What can you do? You can call directly from Vertex the services exposed by the other microservices, for example. Yes, Vertex supports a lot of protocols, but yeah, Vertex is not an integration platform. It doesn't support all the enterprise integration patterns that Camel was built for this. So a better approach will be this, for example. Create a Camel microservice that communicate with the event bus, and there are two components to communicate with Vertex. And then you use Camel to integrate the other service. And from the Vertex point of view, you just send messages to the event bus. Then they are forwarded by Camel to the other microservice. And you can do the same from the opposite direction. And you can also put there messaging broker or other thing that you want. The goal is to create a bigger reactive system in the end, using Camel to bridge them. But yeah, before talking about reactive integration in reactive systems, okay, we should have a way to communicate streams, to share data, to share events in the same JVM. And there is this specification called Reactive Streams that solve this problem. It is a set of interfaces that let reactive application to communicate. For example, Vertex, Project Reactor, and Apache Camel can communicate using that interfaces. Basically, you have a publisher that publishes events, and you have a subscriber that subscribes to the publisher and receives event using this onNext function. And then when the stream is over, it receives an incomplete or an error in case of errors. And the stream is finished. And in Java 9, you will find these interfaces under the Flow, Java Flow package. So, okay, let's start with a demo. I will show you how to use Camel with this reactive application. I will put in the middle, also a microservice using a Spring Boot 2 with Webflux, Vertex, and a gRPC microservice. Okay. Okay, this is the demo. I've built a bit of code. I will show you first how it looks like. It's a basic demo, actually, but it serves to me to show you the events directly. Yeah, it was an old demo done in the Vertbox. It is a reactive drawing canvas, but I think it is not started, so I don't know what it is showing now. It was a cache, probably. Okay. I can draw. Yeah, really, really beautiful. I can do something. This is the Java logo. Yeah. Okay. Yeah, I'm really an artist. Yeah, but the trackpad is really bad. I would like to buy a MacBook just for the trackpad because it's impossible to work like this. Just for this. So I'll show you the code. I'm not dragging directly to the canvas. I'm using an observable pattern. An observable. Can you see the code? Yes, I think that the screen is really big. What I do here, okay, I can zoom a bit. What I do here is something really easy. I listen for mouse position when the left button of the mouse is pressed. Sorry, the trackpad, okay. And I send the X and Y of the position to the event bus, the vertex event bus, using this channel, draw.positions. Then I listen to draw.points, another endpoint in the event bus, and draw what comes from the server, meaning X, Y, but also a radius and a color. So I receive points. I send point like positions, and I receive circles to draw. Okay, this is how the application works. And from the vertex side, okay, not using all the stuff of vertex, but what I did here is to pump the vertex events from the events bus, from this channel, draw position, into this position that is a Reactive Streams publisher. So I can use reactive programming. And I'm using, in particular, RX Java 2 here. So from this position, I create a publisher. Then I transform each point to a circle using a color. And then I send the result to this point that is a subscriber, Reactive Stream subscriber. Then I pump what is sent in these subscriber points to draw position back to the browser. This is how it works. Okay, easy. But I would like to show how to use also reactive streams inside Vertex. And okay, look, I have a problem here. So if I move too fast, you see that, you see the points, there are events. But I would like to have not so many holes in the line that I draw. So I can use, for example, another service that I have defined. And where is it? The Spring Boot module as a service that can fill the gaps. It's called fill the gaps. Okay. And if you have seen Spring 5 and the Webflux stuff, you have seen this kind of REST service defined like this. You can define a service receiving a flux of points, a stream of points, and returning a flux of points. So I have an idea. What if I forward the stream coming from the browser to Vertex, then I forward it to this service, and then I take the stream back, and I forward it to the, so I can do a longer circuit passing from Spring Boot. Yeah, but actually, this is not the service that I can use to do this kind of stuff, because yeah, it's like a service where you write here a list of points. Yeah, from the REST point of view, if I write a flux of points and or a list of points, it is the same thing for this service, for this particular service. In Spring 5, you can use also server-sent events. You can use a WebSocket to do that kind of communication, but that is another kind of service. For now, we have this. So we should pass a JSON array to this service and have back a JSON array. How can we do it? I would like to do it with Camel. So I can aggregate the points of a line and then send in batch to this service, because it doesn't support streaming, this service. I'm not setting that Spring doesn't support streaming, okay? So, okay, I want to pass from Camel. How can I forward messages to Camel from Vertex? I can do like this, for example. Instead of sending the points back to the browser, I send the points to Camel, and I say Rx Camel that create a stream subscriber called raw points of type JSON object. And so I forward the messages, the stream, to Camel. And then I take the resulting stream from Camel, from stream. For example, I call it enhanced points of type JSON object. And then I send this resulting stream to the browser. And now I have to define the Camel routes here. So first of all, I take, this is the component, I'm using Reactive Streams component. I take what is sent to raw points, and I send to this special endpoint called SEDA output. SEDA is like an asynchronous buffer used in Camel. And what you send, you can send a message to it and then read the message again from this SEDA endpoint. And okay, I send the messages back to Reactive Streams. I've sent message back to the browser. It was called enhanced points. Okay, I will try if it works before going forward. Okay, it should be the same. Okay, but now I'm passing from Camel. Okay, so I would like to call that Spring service to pass some points. Okay, I don't want to write the route from scratch. I've written it before. So I have this Camel route, it's already pasted, that can call that service. It is using a direct endpoint. Okay, I will show you how it is used. But basically what I do, I set this header called drawing. The drawing is an integer that increments every time I click the mouse in the UI. Okay, and I aggregate everything that has the same integer that belongs to the same line using a flexible strategy, accumulate them into a list in this case. So I collect all the elements that belong to the same line. Then when I have a list where elements are events are not distant from each other more than 50 milliseconds, yeah, I transform this list into a JSON array, then I set the application JSON format, and then I send the message to the Spring Boot service. I take the result, I transform into a JSON array, I split to have the single items, and I send them to the SEDA output, that is the same output that I use. So I need to bridge this endpoint. How can I do it with Camel? For example, I can copy from the wiretap. Wiretap direct fill the gap without us. So we'll try if it works. I need to start the Spring Boot application, I think. Hope it works. Then, yeah, What you have here, that the holes are filled now. If I continue to draw, nothing happens. But when I stop, yeah, you will get the red points inside. So I've injected another stream into this application. So, but yeah, can I do it in a streaming fashion? Yes. For example, I have here a gRPC module, and gRPC can define services. It's not the only way, that receive a stream and return a stream, for example. And I want to use this service. This service is defined here. Basically, look at the main code. I have the input here, and I have a main flow that basically shifts the points by 20 pixels and change the color. And then another flow that does some awesome stuff. Okay, it tries to understand what I'm trying to draw and inject other things into the stream. And can I use it with the Camel? Yes, of course. We have a gRPC module, and I've written the endpoints back here. I can copy. Well, I can send events to this endpoint. I transform the JSON objects into protobuf points. I send to gRPC in streaming mode. I'm using streaming mode here, Camel. It's a new feature of the new version. And then I send messages, the replies, to this SEDA gRPC stream. What is this SEDA gRPC stream? It's this one. I transform the body, the response, from protobuf to JSON object, and I send to the output. I can bridge it in the same way here. Wiretap, direct, another one probably is called. And yeah, if I start it, okay, it started. What you have another stream. When I generate events over the first stream, you have the events forwarded to the other stream, okay, and back. So I've injected another stream into this system. What was the awesome stuff? Yeah, the trackpad is really bad, but I will try to do it. Ooh. Yeah, it works. It understood I was dragging a smiling face. It is using neural network, you know. Yeah. So far, okay, this is the demo. It was useful to show how events can be handled in a streaming fashion. Yeah, I've used Reactive Stream, but I could have used the Vertex Camel Bridge or Vertex components to do this kind of stuff. But yeah, I would like to show how Reactive Stream can be used to bridge different reactive applications in the same JVM. So let's talk about other stuff. Reactive Streams has in its core this kind of solution for a common problem. The problem is this: when you send event to an operator, usually, I don't know how much usually, but yeah, the normal thing is that the operator processes the event and everything flows correctly without problems, without issues. But what happens if you have a slow subscriber? If you have a slow subscriber, you have to buffer the events, so you cannot go fast as you want. And when you buffer, you usually get a point where the buffer is almost full. And if the buffer is full, you cannot accept other events. So what you do? What you can do is, suppose that this is a pipe where water is flowing inside. What water does when there is no more space? Water creates a back pressure in the other direction with respect to the flow. And this is the same concept, the back pressure. So you tell the publisher, I'm not able to process this. And the publisher tells to its publisher, if there is something upstream, the same thing. So you can block this flow until you recover, for example, from a peak. And this is how back pressure works in practice in reactive streams. You have a publisher and a subscriber. The first thing, you subscribe to the publisher, and then the publisher gives you a subscription. And the publisher cannot send anything to you until you request with the subscription some elements, in this case, one event. And then the publisher can send it. They can request 2 events, and the publisher can send two events. This is how back pressure works in practice. And okay, let's talk about a distributed setting where you have multiple microservices and you have clients asking requests to these microservices. What happens is if one of these microservices, for example, microservice 4 is full, it cannot process more requests. It happens that it starts to reply to with HTTP errors in the best case, or just timeouts. And what can you do? With Eastrix, for example, you can, if you are microservice 2, you can return to microservice 1 a different, so a fallback response. If you are doing streaming, well, there is no response to give, you just retry, for example. But what if we had back pressure at distributed level? Like this. Microservice 4 is full, and then microservice 2 and 3 know that it is full. And then, yeah, at the end, events are buffered at the source in this context. Sometimes it can be good to buffer events at the source, but yeah, other times here you have a lot of latency. So it's better to buffer them here if you have space, or here in the middle using an anti-back pressure mechanism. We'll see it later. But well, if you are developing a reactive system, you should be able to handle this situation. First, you delay the operation, the streaming, but you make the system less responsive. But then you have to scale out, for example, a service 4 to recover and go faster. But how can this back pressure, end-to-end back pressure, can work? How can you let two applications share a stream, and if the second application is low, you should go slower? Despacito, right? You have a protocol, for example, our socket that was built for this kind of, it is probably a mapping from reactive streams to a protocol. It uses on X, on error, on complete, and request. Well, yeah, wait. This back pressure stuff is not so new. Do you know a protocol using back pressure? Yeah, TCP. You have the receiver window in TCP. You cannot send to an endpoint more data than it is allowed to handle. So TCP is back pressure aware, but how can you transmit this back pressure up to the application, up to the stream? Yeah, one way to do it can be this. Basically, you have the application. You don't have to write too much to the TCP buffer from the sending side if the TCP buffer is full. And then forward this back pressure back. And from the reading side, for example, you should not read from the TCP buffer if you cannot process, if you are blocked by some back pressure downstream. This is a way it can work with other protocol, HTTP, WebSocket, server-sent events. Yeah, but it's not so easy. We will try to implement something like this also in Apache Camel, but yeah, everybody talk about this end-to-end back pressure, but yeah. It's like teenage sex, nobody knows how to do. Okay, but yeah, Camel can use back pressure in many situations. For example, look at this one. We have a Rex Java stream going through the reactive stream components to Camel, and then Camel communicate with an external service. You can set the throttle with Camel. So don't send more than 3 messages to that service in 10 seconds. Or don't create more than 20 concurrent connections to that service. So you wait for the request to be processed by the other service before putting other requests. And you communicate back pressure to Rex Java. So you have flow control. This is another situation. You have a messaging broker, ActiveMQ, Kafka, MQTT, okay. Camel supports a lot of protocols. And what you do is this. If you have a subscriber that uses reactive streams, that subscriber communicates with Camel using back pressure. And if it is low, Camel stops reading from the message broker, wait for the subscriber to recover, and then continue. So, and you have a lot of other features. If you look at Reactive Manifesto, yeah, you need to give elasticity to a reactive system. You have a client-side load balancer in Camel. How can it be useful, a client-side load balancer? Well, suppose that in that application that I showed you before, you want to send all the messages coming from one canvas, from one user to the same microservice. How can you do? With Camel, we just define a load balancer using a sticky expression. Messages, events from the same canvas FD should be goes always to the same microservice, to the same target microservice. Yeah, load balancer also support round robin, random failover also if something fails. And we have a bit of location transparency using, for example, a service registry. You don't have to contact directly the IP address of one service. You can use the service registry like console, Kubernetes, Ribbon. Just name the service and Camel will look up the service to call. But yeah, location transparency and resiliency using Camel approach can be obtained also in another way by using, for example, a messaging broker. Location transparency is like sending messages to channel queues or topics. And messaging brokers with Camel support a lot of messaging patterns like in-only, in-out, publish, subscribe. So what you can do is put Camel in front of the messaging broker and send events, and Camel will support back pressure. And then from the reading side, the same thing, a Camel consumer. I've showed you the slide before. Camel support back pressure also in this direction. What you can put here is an anti-back pressure. It is called like this Kafka. Kafka can scale out theoretically how much you want. So if you have a lot of instances, practically you can put a lot of events into this kind of system. So in theory, you don't have to worry about the back pressure. This is a way to cache event, not in the source, in the browser, but yeah, or inside your system. And yeah, I think we are finished now. So yeah, if you have questions, this is the right moment, because we have some time. Questions? Yeah.
Hi. Very nice talk. Thank you. I have one question. Maybe it's a bit off topic, but why do you think that, I don't know the percentage of talks about reactive in Java this year, but it's something like maybe 20-25%. And this has been around in other platforms such as Node.js or Python for some years already. Why now Java?
Yeah. Yeah, well, okay. Do you like JavaScript? Yeah, Java is one of the most used languages in the world, and I love Java. You cannot say anything bad about Java. But yeah, what I say here is about Java, but yeah, there are a lot of languages based on the JVM that are going to adopt this same concept. So yes, it's not like about Java. What I'm talking about is a different approach. It is a faster approach. It uses less resources than classical approach. So using less resource means spending less money at the end. So Java is following this train with the other languages. So this is a conference mainly about Java and talking about Java. And it is my mother language, I think.
Thank you.
Welcome. Other questions? Okay. So thank you very much for being here. Hope you enjoyed it.